One fine morning, you decide to take a walk. First, you walk 2 kilometers in a direction 30 degrees north of east. Call this motion vector A. After this, you continue your walk by moving a distance of 3 kilometers in a direction 10 degrees south of west. Call this motion vector B. Then you get a text message on your phone requesting that you return home ASAP. Throughout this problem, please use east as the x-coordinate and north as the y-coordinate. As with many vector problems in a physics class, the vectors have been given to you by specifying their magnitude and direction. However, in order to do the mathematics, we're going to need to express both vectors in component format, and that's exactly what we're asked for in Part A. To express the vectors in component form, the first thing we're going to do is draw them. Vector A is 2 kilometers in length and is in a direction 30 degrees north of east. That means beginning with the direction east, we go 30 degrees north of that axis, so that the vector A will look like this. And we're ready to express this in components. We can call the components I, J, K, X, Y, Z, or actually a little more straightforward is to simply call them east and north. And that's what we're going to do. Preparing our expression, we see that we need to determine what is the east component and the north component of vector A. Vector A has both of these components, and we draw a triangle by following one axis until completing the triangle follows the other axis. So we have an east component and a north component. The east component is the side adjacent to the 30 degrees, and therefore it will be 2 kilometers times the cosine of 30. And the north component is opposite to the 30 degrees, therefore that one will be 2 kilometers sine 30. We can simplify this by calculating out the sine and cosine, yielding 1.732 kilometers east and 1 kilometer north. Repeating the same thing for vector B, we notice that vector B will have a magnitude of 3 kilometers, but in a direction which is south of west. So beginning with the direction of west, which is to the left, we will draw our vector 10 degrees south of that. Similar to the previous step, we'll need to express B in terms of both its east component and its north component. As always, to make components, we follow one direction, in this case west, until finishing the triangle is in the other direction, which is south, meaning that both the east and north components of the vector B will be negative. The east component is adjacent to the 10 degrees and is therefore 3 kilometers times the cosine of 10 degrees, and the north component is opposite to the 3 kilometers, so it is therefore 3 kilometers sine of 10 degrees. We simplify this expression by calculating out the sine and cosine, so that the east component of B is negative 2.95 kilometers and the north component of B is negative 0.521 kilometers. In part B, we're asked how far away from home are you when your cell phone rings, and to calculate the magnitude of the resulting vector, not just the components. As compared to a simpler vector problem, we are not told whether we should add or subtract these two vectors. We need to figure that out for ourselves. If we make a diagram of the walk, we'll find the following. The course of our walk has taken us northeast in accordance with vector A drawn in red, followed by southwest in accordance with vector B drawn in blue. That means that our final displacement as compared to the original location is given by the black vector. Looking at this diagram, we recognize that the black vector must be equal to the sum of vectors A plus B. Therefore, we need to find the magnitude of the sum of A plus B. A plus B will have an east component, and it will also have a north component. Please note that the diagram I have drawn is not necessarily to scale. However, the mathematics will still give us the correct result. The east component of a plus b is obtained by adding the east components of a to the east component of b, yielding negative 1.22 kilometers east and positive 0.479. Since we're asked to find the magnitude of this vector, we will need to take the two components, square them, add them, and take the square root, which yields the algebraic result, 1.31 kilometers. Lastly, we're asked, what is the direction from home to you when the phone rings? Well, looking at the diagram in the previous part of the problem, we can see that the vector a plus b, drawn in black, is indeed in the direction of home to you. So to find the direction of that vector, we do it the same way as for finding the direction of any other vector. We set the tangent of the angle of the vector a plus b equal to the ratio y component over x component. We recognize that when taking an inverse tangent with our calculator, we will always retrieve a result in either the fourth or first quadrants. However, when the x value of a vector is negative, this answer is either in the second or third quadrants, and we need to take the calculator result and add 180. Thus, the angle we find for the vector theta a plus b is 158.6 degrees.